Hi, my name is Marc Bissell and I'm the Senior Applications Engineer for CAMWorks. In this video, I'd like to discuss the difference between 4 and 5 axis machining and how this can affect part design. From a design standpoint, it can be difficult to tell the difference between parts that require 4 and 5 axis machining. However, from a cost standpoint, it's easy to tell the difference because 5 axis parts are typically more expensive. Let's take a look at an example. Tubular frames are often used in the design of motorcycles, dune buggies, and off-road vehicles, just to name a few. To construct these tubular frames, the ends of the tubes are typically mitered, or sometimes called fish-mouthed, so they will fit nicely to another tube for welding. Using SolidWorks, I was able to easily create a cut to miter the end of the 2.5-inch tube so it will fit up against the 3.5-inch tube at a 10-degree angle. I'll suppress the 3.5-inch tube so we can take a closer look at the mitered end. At first glance, you might think because we are working with a cylinder, this mitered end could be machined using 4-axis, but that is not the case. Using CAMWorks, I've created a 4-axis toolpath to machine the end of the tube. Let's simulate the toolpath and see what happens when 4-axis are used to machine the end of the tube. Now that the simulation is complete, let me delete the remaining portion of the part that was removed, and then let's use CAMWorks Compare feature to compare the cut model to the design model. Using this exclusive CAMWorks feature, the remaining or excess material appears in blue, and the areas displayed in red are where the part has been gouged. This result occurs because the surface being machined requires the tool to tilt relative to the end of the tube while rotating. But a 4-axis machine is not able to tilt the tool. Only a 5-axis machine has this capability. Let's look at a side view of the part and run the simulation again. Notice how when the tool rotates around the cylinder, it always remains vertical or parallel to the end of the tube. Now let's suppress the 4-axis operation and take a look at how a 5-axis machine could be used to correctly machine the part. Let's simulate the 5-axis toolpath and see how it machines the end of the tube. Now that it's complete, let's rotate the view a little and then delete the portion of the tube that's been removed by machining. Next, let's again use CAMWorks Compare feature to compare the machined model to the designed model. This time, we can see everything is in green, which means the part has been machined exactly as it was designed. There's no excess stock in blue or gouge areas in red like we saw when simulating the 4-axis toolpath. Now let's look at a side view and again run the simulation. This time you can see the tool is able to tilt as it rotates around the cylinder, and if I pause the simulation, you can plainly see that the tool is tilted relative to the end of the tube, and this tilting allows the surface to be fully machined. I hope you're beginning to understand the difference between 4 and 5-axis machining. No matter what CAM system is used, surfaces like this one can only be machined with a single cut using either 5-axis or special tooling, both of which add cost to the design. If we want to reduce the cost of the part, we must design the part to be machined using only 4-axis by making sure that the machined surfaces are always parallel to one of the standard work planes. On this part, the end of the tube was mitered using an extruded cut in SolidWorks and a circular sketch that was the same diameter as the outside diameter of the mating tube. Now let's look at another version of this part. On this part, the end of the tube was mitered by using a swept cut in SolidWorks. A 3D sketch of the intersection curve was created first. Then a sketch representing the cross-section of the tool was created, and the sketch was swept using the 3D curve as a guide curve. The end result is a part that doesn't fit up quite as tight against the mating tube, but is actually a better design in that it allows more weld penetration and is less expensive because it can be machined using only 4-axis. Let's go over to CAMWorks and take a look at the 4-axis toolpath simulation. As I run the simulation, you can see the tool is staying parallel with the ends of the tube. And if I use the compare feature to compare the machined model to the design model, we can see that everything is in green, showing that the part has been machined correctly to the design. Next, let's get a side view and run the simulation again. This time, when I run the simulation, you can see that the tool always stays parallel to the end of the tube, just as it would on a 4-axis machine. On the actual machine, the part would rotate rather than the tool rotating. And in the next video, we'll use CAMWorks Virtual Machine to accurately simulate the machining process directly from the G-code that will run the machine. I hope you've learned the difference between 4 and 5-axis machining and how it can affect part design. Thank you for watching this video.